Hey, what's up, Bloomfield, and welcome to this edition. So today we're going to be talking about slope and looking how they interact at a rate of change. So some word problems coming at you hard today. So let's go. All right, so when we're talking about slope, we know we're talking about our m, right? So that's our slope. And so slope we can also think about as rise over run, or we can think about it as y over x, or change in y over change in x. So we're looking for how does y and x relate, right? How are they related? And so we can also think about the rise, which would be the change in y, or how do they change? And sometimes we use this abbreviation y2 minus y1 over x2 minus x1. So all that means is just the difference in the y's. So the difference in the y's divided by the difference in the x's. So on example 1, we can take our difference in our x's and difference in our y's. So difference in the y's, and it doesn't really matter whether I call this y1 or this y2. So I'm just going to call this 2.2 and this 0.1 just because it comes first, 1 and 2. So in this case, I'm going to do negative 4 minus 5, and we're going to divide that by negative 2 and minus 4. So now I get, that would give me negative 9 over negative 6, or in that case would give me, if it simplifies, to 3 over 2. Because I'm going to let you do example 2. All right. So here we go, example 3. I know I'm going to do, let's call this once again 0.1, this 0.2. So if I did 10 minus 8 divided by 4 minus 4, well, what happens there? Well, that gives me then that's 2 over 0. Well, we know we can't do 2 divided by 0. So 2 divided by 0 is undefined. Right? So that's undefined. Well, what happens on an undefined slope? What does an undefined slope actually look like? Well, let's think about that for a second. So we know it's rise over run, right? So that means it rises to and it goes nowhere. So we can say, well, that's rise over run. So once again, it rises up 2 spaces, but it runs nowhere, so that's an x. So this is a vertical line. So vice versa, let's look at example 4 and see what happens there. Well, example 4, we know I'm going to do y minus y. So I'm going to do negative 2 minus negative 2. And I'm going to do negative 3 minus 6. So that would tell me that is 0 divided by negative 9. Well, what does that mean? That means it rises nothing. So if that was my start, so it rises nothing from here, goes up nowhere, but it runs negative 9. So that would mean it's going to be going over negative 9. So that gives me a horizontal line. So those are just a couple of terms. We know if it rises, so if it rises from left to right, it is positive. So I know if it rises, it's positive. If it falls, it's negative. And now we know horizontal is when I get 0 slope. So there is no slope because it rises nothing and runs everywhere. And it is vertical when the slope is undefined. That means it rises but doesn't run. So it rises up but has divide by 0, so there is no run. So next set of things to think about is parallel and perpendicular lines. Well, a couple of concepts that we really want to talk about. Parallel lines. Right? What happens in parallel lines? Well, when they're parallel, we know that they never touch, so they have the same slope. What else do we know? If they have the same slope. So if we were doing equations, if they have the same slope, if they're parallel, we know that they never intersect, right? So they never ever cross. So if we were doing equations, there would be no solution, or there's no time that they cross. All right, perpendicular lines, well, we know that they have to cross at a 90-degree angle. So whatever their slopes are, they have to be, so if I take the slope of 1 times the slope of 2, they have to equal -1. So if the slope of the first line is equal to -3/2, the slope of the second line, so the slope of the second line has to be the inverse. Not only the inverse, but the negative reciprocal. So that has to be 2/3. Now, when I'm going through these notes, one thing I want to make sure you do, because I don't write everything, but I do expect you to write the things that you think are important. So when I say like for instance, perpendicular lines, I said they were negative reciprocals, right? So you should put that in your notes, that they are negative reciprocals. Just because I didn't write it doesn't mean that you shouldn't. So now let's go on to this. We're going to determine, are they perpendicular or are they parallel? So let's talk through these. Well, this one we're going to do, all right, so y2 minus y1. So let's first figure out the slope of line 1. Line 1 I'll do in black. Let's do line 2 in red. Okay, so line 1 we know is going to be then y2 minus y1. So we're doing -1 minus 2. And we're dividing that by 0 minus -2. So what do we get there? Well, -1 minus 2 is -3. And on the bottom, 0 minus -2 is +2. So I have a -3/2. Right? Let's look at line 2. Well, I'm doing 3 minus -1 and 2 minus -4. Okay? So that would tell me that that is 3 plus 1, or 4. And that would be then 2 plus 4, or 6. And that would be 2/3. So let's evaluate their slopes. I have a -3/2 and a +2/3. Well, those look like they're negative reciprocals, and yes, they are. So example 5 is perpendicular. All right, so let's talk through example 6. Well, here I have -3 divided by 2 all over 4 minus 1. Well, that would be, in this case, -5 divided by 3. Okay, and on the bottom, for line 4, here I have -2 minus 3, and on the bottom, -1 minus -4. So that would tell me that's -5, and that would be a -3. Okay, so -1 minus -4 would be +3. So I have -5/3 and -5/3. Those are identical slopes. So that means that these two lines are the same slope, or in other words, they are parallel. Right? Same slope equals parallel. Right, so another way to think about slope is also this concept of rate of change, or what's happening over time. So if I have these two things that are both growing, so between 2005 and 1965, so a lot of times you would see this actually listed in a table. So you could see some kind of table listed. So this same problem may look like this, where you have, what? So I have 1965, and I have 2005, and we have then 137 and 141. Okay, so well, time is always this, so this would be on our x-axis. When we list it in a table, whatever comes first or the table is always x, and this is always y. Right, so x before y. Right, it's alphabetical. So same concept, it's exactly the same type of problem that we were just doing. We just want to find predicted diameter in 2065. So how do I find that? Well, I got to find out what's the slope, or what is the rate of change. How much time is it, what is changing every single year? All right? So I know that the difference in this, so 141 minus 137 divided by 2005 minus 1965 will tell me how much it changes in 1 year, right? Or the rate of change per time, right? How much it grows over time, right? That's what that means, growth per time. Per means divide, or y divided by x, right? So 141 minus 137 is 5. So I have this is 5. 2005 minus 1965. All right, so that would tell me that it has to grow 1/8 of an inch every year, or my slope would be 1/8 of an inch. Okay, so, well, we know we've got to go up to predict the diameter in 2065. Well, I can take 2005 and go, so that's telling me that I got to go 60 more years. So if it's going to gain 1/8 of an inch every year, well, what's 60 times 1/8? Okay, and this is where I remember that little trick that I told you how to simplify before you multiply, right? So both of these can be divided out. So instead of having to do 60 over 8 and then simplify, let's go ahead and simplify that out and see what is that. All right, so that means that I got 15 over 2. That's how much inches that we've gained in 60 years. Well, where did we start at, though? We started at 141, and we have to add 15 over 2, right? So let's see, what is that? Well, 15 over 2 is 7.5. So if I add 7.5, that tells me that I get 148.5. So that would be the size of our tree in 2065. All right, so here we go on this one. A car uses 3 gallons of gas for 50 miles on one trip and 9 gallons of gas for 140 miles. So on another trip. So we got to just figure out what would X be and what would Y be. Well, it's almost always in word problems. What they list first is typically the X, and what comes second is the Y, usually. So that's kind of the same way here. This would be X, this would be Y. So I know we can just find average rate of change. It's just looking for the slope. So we're just doing 140 minus 50, and we're dividing that by 9 minus 3. And there we go. Bada bing, bada boom, ain't nothing but a thing. So that is 90 divided by 3, which is 90 divided by 6, which gives us a fraction that you guys got to simplify. All right, so here's a couple of problems that I want you to actually try out. This is what I'll be looking for in your notes as well, based on problems that we've already done. So try those out. And the very last thing I want you to be able to do is actually summarize the entire notes. So describe everything. So make sure you include how to find slope, what is the difference in rate of change. Try to summarize and put all of that in 3 sentences or less. Be as descriptive as possible and describe all the intricacies and details between slope. Make sure you understand parallel and perpendicular lines. So, and then we will discuss what you summarized and how did you actually explain it. So be prepared to explain these types of things in class on Monday. All right, guys, have a great day.